Today, I'm going to tell you the most important things you need to know about biofuels. And so, biofuels are this subsection of the biomass category where we're using biomass as an energy resource. But in this case, we're taking solid biomass, whether it's from waste streams or from energy crops, things like that, and we're converting it into a liquid or a gaseous biofuel to be used in different places in our energy system. Today, we're really going to focus on liquid biofuels that we're using in our transportation sector. Biogas is still a pretty small sector. We talk about that more in our biomass lecture, so you can go check that out there. So why do people want to use biofuels? Why do we want to use them instead of fossil fuels? What's the argument? A lot of times people talk about it as the potential to be carbon neutral. And the idea to making a biofuel carbon neutral is that you're growing a plant or a crop or something that's absorbing CO2 when it's growing. You make it into the biofuel, you burn it, you re-release that carbon as CO2, but then it should be reabsorbed by the plants that are growing again. The challenge with actually thinking about this as being carbon neutral is that there are energy inputs to all of the different places in this system, which pretty much makes it really hard to actually have a carbon neutral or a carbon negative biofuel. And so when we look at the full system analysis of a lot of these biofuels, they don't actually come out to being carbon neutral or carbon negative. The main biofuels that we use today are ethanol and biodiesel. So these are used in different kinds of engines. Ethanol is used in gasoline engines, so internal combustion engines. Biodiesel is used in diesel engines. Both of these cannot be used 100% in just a gasoline engine or a diesel engine. So with ethanol, you can add it to gasoline up to about 10%, maybe 15% of it being ethanol and run it in a normal gasoline engine. For biodiesel, it's only up to about 20% limit on biodiesel being added to diesel to just run it in a traditional engine. There are engines that are designed to operate at higher percentages of those biofuels, but for just a typical engine, that's kind of your limit. Some of the things to know about these fuels, like ethanol, for example, ethanol is a much lower energy density than gasoline. So it takes about 1.5 gallons of ethanol to equal 1 gallon of gasoline. So when you're adding it to your fuel, you're actually lowering your fuel economy of your vehicle. So you're having to fill up more often. Now, ethanol does add other features to your fuel. Octane booster, it's an oxygenate, which can help with some of the air pollutants that are coming out of the tailpipe. So there's other reasons we add ethanol, but just from an energy standpoint, it's lower. These other things I put in here, renewable diesel is something that's growing. We'll talk a little bit more about renewable diesel versus biodiesel. Renewable diesel is actually what we call a drop-in fuel, meaning that it chemically is the same as diesel. And so you can actually replace diesel 100% with renewable diesel. Biodiesel, renewable diesel, these have some of the same sources. It's just a different process to make them. And so although the majority of diesel replacement that's biomass based has been biodiesel, renewable diesel is really where we're seeing a lot of the growth today as we figure that out. And we'll wrap up and talk about sustainable aviation fuels, another area of biofuels that's up and coming. So globally today, like I said, it's really ethanol and biodiesel that dominate biofuels globally, but you can see renewable diesel is where we're seeing most of the growth happen. And again, it's more useful in a way because you can just directly replace diesel with the renewable diesel. Now, to put that in context, this is looking at all of the transportation energy consumption in the world. Biomass is a very, very small portion of that. It is still very much dominated by oil. Most of the biofuel production is concentrated in a few countries, which happen to be the same countries that are using those biofuels. So much of the biofuels are produced in the United States, Brazil, and the EU. The United States and Brazil, it's really ethanol, so we'll talk about that first. And then the EU, it's really more diesel replacements. The reason that the United States has a lot of growth in biofuels is related to two policies. So a lot of these places, Brazil, Europe, the biofuel usage is driven by policy measures. In the United States, we have something called the Renewable Fuel Standard, which was put together actually to try to lower the carbon intensity of our fuel system. Much of this fuel standard has been met by what we call conventional biofuels. That's corn-related ethanol. But there's incentives to do more with advanced and cellulosic biofuels. Those just haven't worked out economically at scale. So we're really at the point right now where 10% of the gasoline in the United States is ethanol driven by these policies. The other policy that actually is really impactful because California has a large transportation system. It's if it was its own country. It would be third or fourth largest in the world in terms of gasoline consumption. It also has a carbon standard for trying to lower the carbon intensity of fuels. And so this is also driving biofuels into the system. In this case, a little bit different. It's not corn ethanol, it's sugarcane ethanol in order to meet California standards. And there's been a lot of growth in renewable diesel in California driven by this policy. So let's talk about the United States as an example place that is using biofuels because it's one of those kind of three main regions in the world that is using biofuels. In the United States, it's primarily ethanol, again, driven by the renewable fuel standard. But you have seen this growth, especially in renewable diesel. A lot of that's driven by the California standard. Okay, so there's kind of two big ways you can make biofuels. And so I'm using ethanol as an example. You can use the sugars from a plant. That's the stuff we eat. So like if you think about corn, the sugars and the starches, that's the cob, that's the part that we're eating. It's relatively easy to break down sugars into an alcohol like ethanol. It is the same process that we use to make beers or wines. Ethanol is actually the alcohol that is in our beers and things like that that we're drinking. So it is fermenting those sugars into the alcohol. This is a process we've known how to do for a long time. It's a relatively easy process. Now, the amount of indirect emissions or indirect impact for different crops can be very different. And so I've given you two examples here showing that sugarcane actually is a much more land effective way of making ethanol. In other words, it doesn't take as many acres to make the same amount of ethanol as it does with corn. Corn actually is a much more energy intensive crop. It's a much more land intensive crop than sugarcane. So you get kind of a different carbon accounting when you're doing sugarcane ethanol versus corn ethanol. So if we go back to like the California standard, corn ethanol doesn't meet its standard, sugarcane ethanol does. Now, cellulosic ethanol or cellulosic biofuels, this was meant to be the advancement that was going to happen and was driven by policy because this would be a much lower carbon system. And the reason for that is you would use the rest of the plant, not just the sugars, but you would use the leaves and the stalk and the leftovers, and you could use switchgrass that grows on this hillside. So you weren't using this valuable agricultural land. So if we could break down the leaves and those kind of things into the alcohols, that would be a much less land intensive and it wouldn't compete with our food crops in the same way fermentation does. We can make ethanol out of cellulosic resources. We have not been able to do it at scale at anything that comes close to economically. And so cellulosic production is pretty much at near zero in terms of making biofuels. Okay, so we're talking about ethanol. As I mentioned, Brazil and the United States really dominate in our biofuels. For ethanol in particular, it's the US and Brazil that dominate global ethanol production. And that's also where we're using a lot of the ethanol. In the United States, this ethanol demand from our policies has really grown how much corn we are growing. So you can imagine the land use impact that this policy has had, almost doubled our corn acreage in the United States. And at times, this policy really puts pressure on prices for corn. The US is the world's largest corn exporter. A lot of times that corn is going into food that is a large part of a lot of people's diet. And so in times, especially when there is drought and the corn crop is lower and therefore it drives up prices, it can really put pressure on food staples. So it is controversial, I would say, to use this food source for a fuel because of the impact it has on food prices for people around the world. All right, so that's a little bit about ethanol. Let's talk about biodiesel for a minute. So before we got kind of renewable diesel, biodiesel was kind of the other biofuel that is being produced. Again, the United States and the EU are really where biodiesel production dominates. But I want to give you a sense of the scale of that. So even though these are the two largest countries making biodiesel, that biodiesel use is still very, very, very small portion of the diesel demand in the United States. And we see similar numbers in the EU. Renewable diesel has really bypassed biodiesel, again, driven by that California policy. So California is consuming almost all of this renewable diesel as part of their meeting their low carbon fuel standard. But even that, it's a very, very small portion of the overall diesel demand. And so this is looking at today, it's only about 7% of diesel production and isn't expected to grow all that much. Maybe if diesel demand actually comes down, it'll be somewhere around 15% of diesel production in 2050. So They've made some inroads into these sectors, but they're not meeting a huge portion of the energy demand. Finally, just to give you kind of a summary of biofuel concerns, if you go back to our biomass lecture, they kind of have the same concerns as biomass in general because they're biomass resources, right? So when we're thinking about land use, habitat, deforestation, these kind of challenges, doing it in a sustainable manner, biofuels have all of those same concerns. We also see additional concerns with biofuels. There's a lot more energy that goes into processing a biofuel because you're not just using it as the biomass resource. You have to make it into a biofuel. So there's a lot more energy input, a lot more life cycle carbon emissions than you might see with even some of our other biomass resources. So the carbon intensity and the energy intensity tends to be higher. You have this food competition. One of the impacts that we've seen in the United States as we grew the amount of corn we were drying, the amount of acreage we had of corn. Corn tends to be a pretty water intensive and fertilizer intensive crop. We started seeing growth in what are called dead zones in places like the Gulf of Mexico and Chesapeake Bay, linked to this increased corn production for ethanol production, where we're just getting more runoff of fertilizers into our waterways that then cause an algal bloom that then sucks up the oxygen in those areas. And so everything that relies on oxygen to survive dies off. And the final thing I want to just mention is depending on what resource we're using for either ethanol or our biodiesel or our renewable diesel, you have different impacts. Some areas use palm oil, for example, for biodiesel or renewable diesel. And a lot of that's coming from Indonesia, where we've seen the palm plantations really taking over the habitat of things like orangutans. So, what's the future of biofuels? So, we're not seeing a ton of demand and growth in ethanol or biodiesel. We are seeing a little bit in that renewable diesel in places like California, but it's not a big portion of our transportation energy sector. Where a lot of people are kind of focusing, I think, now for the future of biofuels is this where we're going to be able to make sustainable aviation fuel? Are those going to be some sort of biofuels? Aviation is one of those sectors that's really hard to decarbonize because you're carrying your fuel around with you and on an airplane. And so weight really matters. The volume really matters. So liquid fuels are often looked to as an option. And so we are seeing some interest in biofuels as sustainable aviation fuels. Just wanted to give you a sense that we're really early days in sustainable aviation fuels. Today, it's much, much less than 1% of the aviation fuel in use. And most of that right now is from used cooking oils and grease. But those are pretty limited resources in terms of being able to make fuels out of them. So they don't meet the scale of actually the amount of aviation fuels used worldwide. So that's kind of what's going to happen. We'll have to kind of watch this space and see what happens next. If you want to know more about biofuels, check out our full lecture and our page, and do join our energy spotlight if you want a little energy lesson in your inbox.